Today we'll be starting with a short introduction. I'll let you know a little bit about Plant Protein Alliance, and then we'll have our feature presentation around extrusion technology, followed by a 20-minute question and answer and some closing notes to let you know what next events are. So I'm Shannon Snaden. I'm the marketing specialist at Plant Protein Alliance. So I help with all the technologies around these webinars and the promotions. Barb is the communications manager. She runs all of the social media accounts and does a fantastic job. She also coordinates the newsletters. Volker Lammers is our special guest today. He's the platform manager at DIL and is a subject matter expert when it comes to food innovation. As well, we have Karen, who is the head of the DIL office, which is a new office located in Calgary, Alberta. And we're very happy to have her here and have some different opportunities when it comes to doing value-added processing of our agri products. So the Plant Protein Alliance, it's all about connecting people to help Alberta become global leaders in plant-based ingredient processing. So most of plant-based proteins that we produce in Alberta, we just ship them off to either China or the United States. And there's not a lot of processing that's happening in Alberta. And this is a great opportunity for us. So we're working together to facilitate the development of a diverse, profitable, and sustainable plant protein ingredient processing industry in Alberta. And to do that, part of what we offer is different networking events, workshops, to teach people about the skills that they need. And to bring people together to have those partnerships that they need to have that thriving plant protein ecosystem. And we do get pretty positive results from our events that we've had so far. We also have 2 monthly newsletters. So the first one features news and stories about plant protein, as well the second one features all the different member updates that we have. So if you're interested, you can sign up at ppaa.ca/communication/newsletters. I highly recommend it. They're very well written and very interesting. As well, if you're interested in helping to support the development of this value-added plant processing, then you can consider becoming a member at the Plant Protein Alliance. We're offering a special incentive currently, 15 months of membership for the price of 12, and you can get that deal on our website at ppaa.ca. And now for the feature presentation with a look at how meatless meats are made with Volker. So Volker, I'm going to stop sharing the screen now so that you can go ahead and share your screen.
Thanks again for PPAA for considering me as a presenter in this interesting topic. I'm pleased to present to you today, and great that so many people joined this webinar today. So the topic is our meatless meats made, and this presentation will hopefully give you a good overview of extrusion technologies, how extrusion can be used to prepare meat analogues or meatless type of meats, and I will also share a few videos of showing demonstrating the technology. First of all, I would like to give a brief introduction of DIL, of our institute. So DIL stands for Deutsches Institut für Lebensmitteltechnik, which is a non-profit research association located here in Northwest Germany, so close to the Dutch border and to the North Sea. Founded in 1983, and we have approximately at the moment roughly 200 employees. And as you see, our headquarters is here in this lovely little city Quakenbrück, but we also have offices in Berlin, Karlsruhe, and Brussels. And now, more recently, one office in Calgary, that's Karin. So that's also how the connection to PPAA was made. So our director and my boss is Dr. Volker Heinz. And the specialty about DIL is our legal status is a registered association. And I will show this in the next slide, what this is. So here's an overview of our campus at DIL. We have a mechanical workshop here, an engineering department. We have like a business and innovation park where startups can be located for new ideas. And then we do a little bit here in the area of feed technology. And we have a Center of Food Physics, which deals mainly on the structure and functionality of foods and applying different physical methods. And then we have our pilot hall for food innovation and process engineering, and this is where my team is also located. As just said, we are a registered association, meaning we have roughly 180 members, being members of DIL. Those are mainly companies from the food, feed, and beverage industry, but also from the machinery and equipment manufacturers are included, and companies from the area around, so small, medium companies, but also startups and large enterprises. And everyone can become a member of our institute. So what are the main topics we're dealing at DIL? It's food technologies. And if we look at this graph here, basically in the food system, we have the nutritional sciences, we have the food sciences and agricultural sciences. DIL is mainly located here in the area of food science. So this is basically focused on food processing. And we say, okay, it's everything from the field until your mouth, until you eat it. Until you eat it, then we need to make the link to the nutritional sciences. So this is our core competencies. We are divided in different platforms here at DIL, and the group I'm responsible for is the process engineering team. And we have basically 4 different strategic pillars. First one, publicly funded research projects. So we apply for federal European funds to do our pre-competitive research. If those are successful, then we try to take these findings and to develop new processes and products with the industrial partners. And the industrial partners can be the members, or can everyone basically who wants to collaborate with us. So we do feasibility studies, product and process development. Then mainly in the area of meat analogues, which will also be the topic of today. We also offer toll production services. So we have a food grade lab where we can produce foods in a high quality standard that can be also used for retail later on. And we have here the wet meat analogues, TVP, but also some other special extruded goods. And beyond that, in collaboration with our workshop, we've developed some type of equipment for extruders, namely the cooling dies, which are needed to produce some type of meat analogues. Those can be used pilot scale up to full production scale. Yeah, our mission is to transfer science into industry-ready solutions. So here in this map, it's just a summary of the collaborations with industry partners in 2019. We mainly are having partners in Germany and Europe, but are also act globally. I don't want to spend too much time today on the reasons why we are all interested in meatless meats and in the technologies behind these 2 slides, because beef is probably one of the most liked meat products. But if cattle were a country, they would rank 3rd in greenhouse gas emissions, right behind China and the United States. And this shows that there is really an impact of the animals, of breeding and eating meat on the environment. And the same is here in the combined greenhouse gases in the same range like the big petrol companies. And so this is the reason why we may need to reconsider our eating behavior. This is also accelerated by this current COVID-19 pandemic. We see that this has an impact somehow on the consumer behavior. So maybe people want to change something and are looking more and more into more sustainable products. And here are some headlines that shows, okay, we may see a shift to meat substitutes now more and more. And this pandemic is accelerating the rise of these type of products. But okay, now let's enter technology part. It will mainly be about food extrusion and protein extrusion, basically. And to create a very good, tasty product at the end, we need to know a little bit how the equipment works and how the screw needs to be configured in the extruder. Then we need to know the protein sources. There are so many different proteins available, but the functionality is quite different. And then, yeah, this dye design is important, but also then how does the structure look like? Does it more resemble like a beef, like chicken or pork or different other type of products? And then what can we make out of it? And this will be, I will give this presentation. This is an overview here about potential protein sources that we've investigated so far in extrusion processes, but may not be complete. So it's just an overview, and it's classified here into plant-based, animal-based, meat-based, and alternative-based products. So why do I include here also the animal-based and meat-based? So animal-based might be interesting for vegetarian products, and meat-based is maybe not for food, but the pet food industry is quite interested in these type of products and making hybrid products with the plant-based ones. Whereas here the plant-based sources are the most applied ones and best known maybe. So where we would consider soy protein and wheat and maybe pea as the golden standards today, where many products available on the market are based on. And some others quite interesting, like lupine, potato, but also sunflower, pumpkin, and rapeseed proteins, which are byproducts from the oil production. And this gives a little bit the loop of how can we use side streams or byproducts from other process industries and use them to valorize them and make new type of products. And this would lead me now to Shannon, to the first poll.
Just let us know, which type of plant protein are you most interested in learning about? Volker's told us about some very interesting ones. I put the ones that are most common to Alberta.
Pretty clear for the pulses.
Yeah.
I would also agree that this is biggest interest, and because the availability is quite good, shows some interesting functionalities, these type of products. This slide is about the protein quality. So it's not only just the source. Every source will have slightly different functionalities and properties, of course. And here, it's just an overview as an example of soy protein, where we distinguish between flours, meals, concentrates, and isolates. On the market, there are different qualities available, and they are classified according to their protein content. You can imagine the higher the protein content, also the higher the functionality is, and also the costs are also higher. And maybe also the processing is more intense. This is just good to know. And then the quality of the raw material not only depends on the protein content, but also on the solubility, fat content, fiber content, and remaining components, which are also still in the mix. So if we have a flour, we also have the carbohydrates, fibers, and other components, which will impact the final structure of the food. And then also the pre-processing of the raw materials is crucial, as it may alter functionality and the native composition of the products, of the raw materials. And then this slide also, and now we make it a little bit different.
What reservations might you have about plant-based proteins? Are you worried about the taste, the ingredients, level of processing? Are you concerned about additives or cost? What's the thing that...
Okay, this is not so clear as the first poll, but I would say it's a good answer. Taste is most important factor. Yes, if it doesn't taste the food, people won't buy it. That is the biggest challenge, that needs to have a good taste. And I'm not saying it has to taste like meat. Maybe taste can be a little bit different, but at least it should be a tasty product. When we're talking about plant proteins, we are often challenged by off taste. Many of the raw materials are quite bitter, have like a typical taste. If you have a pea protein, it may taste a little bit like pea and not like chicken. So those things need to be considered when you create these type of products. Our perspective, from the engineering perspective, the texture is also very important. We need to create similar texture and microstructures as we know it from the meat, because the texture will have an impact on the haptic properties. So do you have the same feeling when you eat it like when you eat a piece of meat? And here the fibrosity, elasticity, and firmness are important characteristics. And also color is important. So if we talk about some oilseed proteins, they may have a greenish color or brownish color. And so this needs to be considered and respected when you develop new type of products. And I think processability was also mentioned in this poll. Yeah. How do you produce these type of products requires some know-how and expertise, and typical factors can be temperature, pressure, shear, and time. I think another one was the additives. How can you create good, tasty products with minimal addition of food additives and other ingredients? I will come later to that, but it's also very important. When we talk about the extrusion technologies to produce vegan products, we mainly consider dry variant and a wet variant. So the dry one, I call it here TVP, Texturized Vegetable Proteins, and HME, so high moisture extrudates. And those two products I will explain a little bit more in detail in the following slides. So here you see the products. They are basically intermediate products, so to say, and these ones are characterized by an expanded product property, by air bubbles, and the right one by a high moisture content and fiber structures, as you can see it here in the image. So basically, the extruder can be very similar for both type of products, and also the source materials may be very similar. So you need a good protein source. You mix it basically with water in the extruder, and then depending on the water content, you principally or simply say go to TVP or to the HME products. And then based on these intermediate products, you can create different type of end products. If we look to this schematic, you see here an extruder, we have a motor, we have a screw section here in the middle, we have a barrel that can be heated or cooled, and we have a die at the end. For the TVP, we have short expansion dies. So we have the TVP and the HME, same extruder setting basically, but differences in the temperature profile and mainly in the die at the ends, and how these dies look like. How the processes are, I will show you now. So for those who do not know how an extruder screw look like, here's an example. These screws can be configured modular, so you have conveying, mixing, kneading elements that are responsible for the right thermomechanical energy input you put into your products. And so now you have mostly heard everything about the theory, and now I will show some videos shot in our pilot plant. Here, powder, the protein fed into the extruder, it's heated up, and then at the end it's extruded through an extruder die or through an expansion die, where an endless strand, or here in this case, 4 endless strands come out of the extruded die at temperatures higher than 100 degrees Celsius. So they expand, and then they are. So there were the endless strands, and when I put a cutter in front of it, I can create small type of pieces. This looks like this. So this process is also known from snack products, puffed cereals, also for breakfast cereals. It's a similar process that is applied. And in some cases, as you still have some water inside the extrudate, you may require some post-drying. This is a belt dryer where we have such a PVP that is dried afterwards. And the benefit is that you have at the end shelf-stable product that you can store for several months, basically. And here we go. Here are some examples of different types of TVP that we've prepared in our lab. And I also have them here. So this one here is a soy protein with wheat flour, so a mixture that is quite interesting. Also, pumpkin TVP looks pretty different. It's this one and others. Yeah, we also have. It's not the plant-based stuff, but also interesting is insect protein. So we also do a little bit on insect TVP and use them for burgers, etc. And how do you make products based on these ingredients? You basically put them into water, so you have to rehydrate them, and then you can see it here. Maybe I put it into water before the meeting, and then they soak up the water, and you have like a sponge structure, and you can further pull it apart. Maybe I tried, if you can see something, I don't know. All the water goes on my keyboard, not the best idea. This is how it works, and then you have different different types with different elasticity, and some may be used better for sausages, some others for chicken nuggets or something like this. So you need to know what your final application will be. Now I will switch over to the wet extrudates, or to the high moisture extrusion. And it's basically the same, similar raw materials, mixing with water, with a lot of more water, and you create these type of intermediate products, and then you can create final ones out of it. And how this work, I will show you in, first a little bit of theory. I talked about the cooling dies first. So we have the extruder. This part is the hot part. It's heated up to, I would say, 130, 140 degrees Celsius. And before it enters the cooling die, it's a little bit cooled down. And in this die, which is basically a heat exchanger, heat is removed by double jacketed of the cooling dies. And then you create such a similar or laminar flow profile inside this cooling die, and the material that is still flowable at the end of the extruder solidifies slowly. And then layer by layer, you create the fiber structure, and this fiber structure is fixed basically in this cooling die. And at the end, you have a semi-solid or solid product with fiber structure. Here you see some examples. Here's a cooling die on the bottom pictures showing the exit of the material. And when you pull this apart, this is always the best test basically to show or to demonstrate the fiber structure. But you will see that depending on your raw material, the structures may be completely different. So you cannot just simply say, okay, I have a protein, I put it into the extruder, and I play a little bit around, and then I get the final or nice structure. No, you have to put in a little bit more of exercises, basically. And if you have a flour, concentrate, or isolate, structures may change. Also on this raw material source, you will create different results. So basically, you need to modify a complete formulation that is a little bit more complex than maybe just one source. So in the extruder, you may blend the raw materials, proteins, maybe optional, some starches, fibers, or other materials. You mix them with water, optionally with oil, flavors, or other ingredients, spices, seasonings, for example. Then after the extruder, you may cup the product, and then this is what we call intermediate product that can be further processed into final products. So to stabilize them, they are not shelf stable, so you may need to freeze them and to thaw, or you directly make the treatment afterwards with some other spices, marinades, or panates, or whatever you like. And then packaging, and you have a final product. Following a few videos, different materials. Oil protein concentrate, water mix that is structured in the sky and coming out of this kind of rectangular cooling die. And this setup is also used in the food industry, and what I think very tasty products are on the market based on this system here. As many people do not like to have soy in their formulations, other ingredients are of interest. One of my favorites is pumpkin seed protein. I just showed the dry variant, so now you see the wet one. And it has a green color. Maybe not everyone likes that, or it does not look from the color like meat, but it has a very nice structure and it tastes good. And what I like the best is really a minimal processed byproduct from the oil production. So this is really giving, from my perspective, or it adds value to this food system. And here you see the structure. So you see the fibers, and also when you eat it, you have a similar bite to a piece of meat. Yes. And here we have a different type of cooling die, which is, I would say, one of our latest innovations to increase the throughput, because you also always need to consider the throughput per hour, basically, to have a cost-efficient and affordable process. And here we can go to much higher processes. This is a pea protein that is extruded. You will see, okay, this is now more like an angular design shape, and here you see a little bit the fiber structure. I made this video on last week, and I just tried it with one hand because in the other one I had the camera, but you see here the fibers, and I think I have a better one in this image. See the long fibers, and I think the beauty of this process is that you really have only the protein source with water plus the extruder, or plus the technology. So it's a very clean labeled product until this point. We would be curious in what type of products you're mostly interested in.
Like a tie between beef and chicken.
Oh yes, the chicken I have here. So some example. I think chicken or the HME process is very suitable for chicken process or for chicken analogues. It can be on a soy basis or pea basis or others. So when you talk about chicken, chicken has like a white color, or it's very light. So you cannot use protein sources that have a very dark color from the beginning on. I mean, you could work with some additives like titanium dioxide or others, but this may not be desired for certain reasons. I think beef is also very challenging but interesting, and fish, we see an increasing interest over the last few months. So many are talking about meat alternatives. Many products are on the market, but more and more fish products come. So very interesting. Thanks for the poll. So just a few images from products we made, like a chicken wrap. If you can make different types of it from the same material. Here we have like a burger patty. And this burger patty is basically based on a mixture of wet and dry extruded proteins. So we think that is good option to improve the texture. To our knowledge today, the majority of the beef or burgers are based on dry products. So also you can make, you can fry them, or you make a panade. And before I will close, I will show you 3 slides about the cooling die equipment that we offer and that we have here. So it's this FKD 750. It's a pilot scale cooling die that is mainly used for R&D purposes. So where we do a lot of product developments, formulation work, develop new type of recipes, testing different ingredients and their functionality. Yeah, it's characterized by 2 cooling circuits, so I can adapt the cooling profile in the cooling die a little bit, and it's operating in the range between 10 to 60 kilograms per hour, and good cleanability. And we can also optional include some inline measurement, which may be interesting from a research perspective. We have a larger one where we also showed a few images. This is this FKD 2100. So the number here, so it stands for flat cooling die, and the number gives you an indication on the cross section of the die, because it is an indicator how much material you can put through the machine. It is modular, can be used up to 4 segments, and we have a higher throughput of between 130 and 240 kilograms per hour. Yeah, and then last one, so the latest die we've developed has this annular profile, and here we can go up to like 500 kilograms per hour. And this is a point where we would say it makes the process, the HME process, really affordable and profitable. This is a figure of our pilot plant. Here we have an extruder, cooling die, and cutting equipment, cooling, and now we will also have like freezing, cryogenic freezing, because freezing is also important. If you have the wet type of product, you need to stabilize it until it gets to the supermarket. We do a little bit of research, as mentioned earlier. Presentation, we have like here on the wet, scanning electron microscopy image of meat analog from soy, and on the right, a muscle meat from beef. I mean, you can see that we have some fibers here aligned that look quite similar and are also in the same size range. So, I mean, this is really microscopic image and does not tell you about how good it tastes, but it gives you an indication that we are able to create similar structures by this technology. And we also developed some type of like tools to determine like the fiber index and to investigate how is the fibrosity, how does it look like. And with this, I come to my conclusion and the summary, just to briefly compare the two processes I've presented. We have the TVP here on the left, the dry products, and the right one, the HME products. I would say the dry ones are easier to work with because they have long shelf life and can be very nicely used for burgers, minced meat, and some sausages. And they are a little bit cheaper because the technology is available on high throughput rates. So there are machines available with up to 1.5 tons per hour. And the HME is a little bit newer technology where we have a wet product that needs to be chilled or frozen or somehow stabilized, but it resembles more like the muscle meat of chicken, beef, and pork. And and at the moment it's available at medium throughput rates, medium to high throughput rates. Yeah. And this is a figure of my teammates in the extrusion or process engineering team, experimenting a lot, having fun in the lab. And with this, I would like to finalize and thank you very much for your attention, for joining this seminar early in the morning when you're in Canada, maybe in the afternoon when you're in Europe or somewhere else. And a big thank you to the PPAA for organizing this event.
So we've got a few questions coming in for you, Volker. So one of the first questions is what the percentage of water is in HME products.
So in HME products, start from, I would say, 50% if you have a ratio of 1:1, one water and one protein. But we normally apply water contents of around 63 to 65% if we have a standard.
And then I guess someone else asked about TVP. So what is the ratio, the moisture ratio for that?
Yeah, so it will be in the process, just as a rule of thumb, around 20%, and then you can dry it down below around 8%, so that you have a stable product from a microbiological perspective also. Yeah.
Okay. And so there was a question about how do you partner with DIL? Like, what's the process of working with you?
Mm-hmm. Yeah, so at the beginning I showed our different pillars, and very important for us are the R&D collaborations with partners from food industry. As I said, can be startups up to large enterprises. And just send us a contact and ask what is your problem, or what would you like to solve, or what you would like to do. Maybe we already have some answers for that, or we can the simplest way is we operate on a service basis, on a daily extrusion rate. You have to pay a little bit, then we do the service, or we do it like an R&D contract and we develop something new together.
Okay.
So different options. We are open.
Right. And just as a note, for in Canada here, you actually have a partnership with the University of Guelph and have equipment in Guelph, right?
Yes. So it was last year that one of the small cooling die was installed in University of Guelph. It was on the professorship of Mario Martinez, but he left Guelph and returned to Europe. So at the moment, I'm not aware who is operating or responsible for that. but if there is an interest, I could ask to make a contact, and they have the same or similar equipment.
Okay. And so I guess just people are asking about moisture. They're also wondering about the temperature for HME extrusion.
Mm-hmm. Yeah, so in the extruder, we have the hot part where we heat up the protein water mixture up to 140 or maybe 160 degrees Celsius. Then also the residence time is important. How long is it in the extruder section? Can be up to 2, 3, or 4 minutes, so to say. And in the cooling dissection, we cool then down to something between 70 and 90 degrees Celsius, typically.
Okay. And then are you mainly using isolates or concentrates as raw plant protein material?
Yeah, so mainly concentrates for the reasons that they are cheaper than the isolates. And if I have an isolate, maybe the texture is too firm because it has such a high functionality that it's really very firm, and you may have to mix it with starches. But this also depends on the source. It's very important. So when I work with soy, we would recommend concentrates, and for pea, for example, pea isolates are preferred. So it depends a little bit.
Right. Okay. And are there bleaching processes to lighten darker proteins to make chicken type?
Yeah, for chicken, we know in some cases or products it's titan dioxide, and this is what we've also used. It works nicely, makes a light color. But like in France, I think it's not allowed anymore, for example. And then some calcium or some others you may add in a low percentage fraction.
Okay. And what's the average shelf life of HME?
Yeah, so if you have like the high water content in it, and it depends on how you pack it. If you just have it chilled, it behaves, I would say, similar to meat. So maybe a few days, maybe a week. Maybe if you pack it like under a controlled atmosphere, it may be longer. Directly after the extruder, it has nearly zero contamination as it comes from the hot machine, but it's a little bit difficult to handle. So to our knowledge, many of those products are frozen at one step, and then you have a long shelf life.
Okay, yeah, so that's why they're frozen, to give them the longer shelf life. So what is the fat and protein content for TVP and HME?
I also have to say it depends on the source.
On the source of protein, yeah.
And on the formulation and on the final product you want to create. I mean, chicken does not have that much fat in general, so you may not add too much oil. But if you want to make like a fatty products, more than 10% of oil will alter the structure formation because it acts like a lubricant or like a grease in the extruder, and then it's a little bit more difficult to bring in the energy and to create the fibers. So generally, it's easier to work with lower oil with oil contents below 10%, just roughly. Okay.
And is there an ideal residence time for TVP?
For the TVP, I would say it can be rather short because, what is important for TVP is that you have only little water, and the protein needs to be hydrated very well. So you need to mix very good, that the water is evenly distributed. But I would say this can be in a few minutes, so 2 or 3 minutes. If you have really high throughput, and then you can adapt a little bit with the screw configuration to adjust the texture or the formation.
Right. So, and for burger patties, can you just talk a little bit about how rapeseed, or what we would call canola protein, works?
Mm-hmm. Maybe I have some rapeseed even here. No, I do not. I don't know if we've made final burger patties out of the rapeseed, so I cannot tell you too much about this. But for every sauce, we do this type of test. So we put it into water. What is the water absorption, and then what is the texture? Is it soft or is it strong? And for the rapeseed, yeah, we have something more like these small TVP stuff. This is now pumpkin, but it looks a little bit similar to this one.
Right. So it's 9 o'clock, which are here in Alberta, so which would be the end of our webinar. Are you good to stay and answer some more questions, Volker?
Oh yeah, I have.
Yeah? Okay, we've got lots of questions. So those of you who have to go, we'll let you go and say thank you for joining us.
Thank you. Yeah.
And we'll maybe continue and answer some more questions for those of you who'd like to stay. So, so this question says TVP binds and releases water, but the high moisture extruded products binds water tightly, which involves not releasing water during cooking beef, the meatless burgers. So do you have an idea to slack the fiber formation in high moisture extruded products?
I'm not sure if I got this question.
I guess it's sort of, do you have an idea so that so that there's not so much water in cooking in the high moisture, like the HME extruded products? Is that a problem in HME extruded products?
I mean, I said in the extruder with HME, I have quite a lot of water, but it's also well binds, basically. And I still also have the option, if I do some post-treatment, that the material can take up a little bit more water even. So to adjust a little bit the softness. If I have a little bit more water, it's getting softer. But I'm not sure if that answers the question.
It's a pretty technical question. Besides insect protein, what other alternative proteins have you worked on using extruder technology?
Yeah, so we once had a PhD here on algae protein, microalgae. That works, but it also relates to a greenish color. And the taste is also, maybe it works for fish products. I don't know. It's a little bit different.
I don't think, yeah.
We've once used with some type of mycoproteins. I think these are a very interesting source. But only a few companies are able to provide that type of material in a good quality. But we've done some very nice tests with some mycoproteins. I like.
Okay. And what effect does carbohydrates or fat have on the texture when using flour or concentrates?
Mm-hmm. So, I mean, when I have a flour, the carbohydrate concentration is already high, maybe higher than the protein concentrate. So, because if I have like a flour or a meal, it's based on carbohydrates, mainly starches, protein, and maybe fibers. So the higher I am with the protein concentration, I may add a little bit of starch to make it the the product a little bit more elastic, I would say. And oil, as I mentioned before, can create some issues at higher addition levels, so higher than 10. Just as an example, the one of the images or videos with the pumpkin, that worked for some reason very well, but it has a low protein content and a high oil content, and surprisingly it's also worked. So that must relate to the protein functionality. So it's not so simple to say it's just protein content or all kind of. And in some cases, when we have high protein values and it is too strong or too fluffy, some fibers may add, because fibers take a little bit more of the water, and this results in different functions, different textures.
Okay, well, we'll just do a couple more questions and then let everybody go. One was about sensory tests. Have you done sensory tests on your products? And is there one protein that is seems more acceptable from that perspective?
Mm-hmm. Yeah, so I mean, we've done internal tests, but we also know from some of our clients what type of products they sell. And we have a consumer science lab, which we've collaborate. And yes, soy, as I said at the beginning, is kind of the golden standard because it has a good functionality, it has a reasonable price, and the taste is also okay. So because it's quite flat taste, so it's easier to put some spices or flavors into it. And it has a good availability. When I have like the pea or some other ingredients, I have these off tastes, particularly for the like rapeseed, maybe pumpkin and partially pea. Then you can try to optimize your formulation, or it's also possible to add some masking flavors. This is what some companies are doing.
Okay. So, all right. Well, I think we've run 10 minutes over, so I think we'll just wrap everything up. And so with the questions. So thank you very much. It's been great to have such a varied audience today, an engaged audience. So Shannon, maybe I'll just turn things back to you just to close things up.
Excellent. Okay. Thank you. Thank you again, Volker. And Karen, thank you so much for coming today and presenting to us. We'll be sending the winner of the engagement draw by email later today. So thank you very much for all your questions that you have all sent in. It was much appreciated and really helped add to the discussion. A couple closing notes. The next webinar is going to be following along this journey. So we've seen how is the plant protein extruded and created, and then what happens next? How is it turned into an actual product? So we'll be learning about that with the NATE Culinary Institute. They'll be doing a plant protein cooking demonstration on June 29th and letting us know some of the things that they're working on in their innovation lab. We'll be sending out a survey after this, and we do ask that you fill it out so that we know how to improve. If you're looking to get in contact with Volker or Karen, you can learn more about what they're working on at their website, dil-ev.de. As well, we can include this in the email that we'll send out after. The webinar video will be posted in a few days on ppaa.ca. As well, we'll send out a link to everyone shortly after the event. And we thank you so much for attending the 5th webinar. So webinars are a new way of sharing information with our members and their guests. And we thank you so much for coming and hope to see you at another one. Thank you. Bye-bye.
Thank you, everyone. Bye-bye. Have a good day.
Thank you.